Hi, today we're going to look at a few of the advanced features of ABACUS 3.0. You should have already watched the walkthrough that shows some of the standard features, so now we're going to look at particularly how to analyze an architecture. First of all, let's evolve the latest architecture here. Now if we go in to look at one of the views in this architecture, particularly the vertical slice related to managed customer service, you should remember that from the previous walkthrough, and it shows the people, the processes, the systems, and then the infrastructure on which it runs. So let's have a look at some of the properties here around the strategy and operations division. We can see that here through the properties tab that the utilization is 88%, so it's quite high. So one of the first things we might want to do is look at what the benefit of adding a person to that team will be. So we simply just change the number there from 5 to 6. Now we also need to do it down here to take into account the cost properties. Okay, going back to our architecture now and to this particular managed customer service view, we can also look around at various other places to see where there might be opportunities to change things. So for example at the branch store here, if we look into there, you can see that the utilization is actually only at 50%. So there's an opportunity to actually get rid of some people here. So let's change from 10 down to 8 people in the branch stores. Okay, so if we now go back to our view, we've made some people changes, just simple property changes, but we will remember that when we were looking at the architecture before, we knew that this HO1 server here was quite lightly utilized. So we can see there that it's 63%. Okay, but it's also quite old. So what we'd suggest is let's try retiring that server and putting the application that runs on it across on the server next to it. So that's this IVR application here. So it's a simple click and drag to move this hosts relationship across here onto the HO2 server. When we drop it there, it asks where do we want to bind it, to the host port. So we now have put the IVR application running on the HO2. So it's a simple matter now of deleting this HO1, just a right click, delete it from the model. It asks us if we'd like to delete any of the connections, so we'll say yes, and you'll see that the diagram's updated there. So as simple as that, we've just added some people to one team, taken some people off another team, and done a technology change. So we want to have a look at some of the benefits and costs of this. Firstly, let's have a look at the cost. So we run a simple TCO calculation against this latest evolved architecture for 5 years using the dollars currency. So we just select the architecture there, provides a whole lot of warnings which we'll ignore for now, and we can continue on. After a brief time you get this the calculation complete dialog, and we know now that we've gone through and done a full calculation for cost. So if we look at this architecture, particularly here, the architecture node, overall we can see that the costs here for the next 5 years will be $21.9 million. Okay, so 21.9. Now if we go here and compare that to what they would have been if we didn't make this change for the 5 years, we can see that it would have been 22.5 million. So it's basically a $600,000 cost saving by making these changes. But of course we expected that, I guess, by retiring people at the branch and retiring a server. But let's have a look at what impact that might have on performance, because we've got to look at the trade-offs here. So now we'll run a performance simulation. Again, choose the architecture that we want. Okay, choose the portion of the architecture that we wish to simulate, in this case the normal running during the day portion. Click finish, and it'll give us a warnings dialog again of all the different warnings, so we'll ignore those for now. And again we go into doing a simulation. Now in this case we're doing a discrete event simulation, so what's happening here is it's passing all the different messages around the architecture and gathering statistics along the way. So we'll be looking at the utilizations of all the different resources, being the people and the technology. It'll be looking at the response times, looking at all the different queuing and all those different things to understand what is the overall performance of this architecture. Now what we're expecting here, of course, is that we decrease the amount of people in the branch store, so that 50% utilization, we'd expect it to go up a bit, as opposed to in the strategy and operations where we added some people, we'd expect that utilization to go down, and we can have a look at the HO2. So let's do that now. The simulation's finished. Took 40 seconds there to do, which is quite impressive. Okay, so let's go and have a look at the branch store. If you remember, it used to be 50%. Now we're looking at it here and we can see that it's 62%. So that's acceptable. So we've obviously increased the utilization there a little bit. Now overall what we really want to do is actually have a look at the utilizations for, sorry, not the utilizations, the response times for all the different transactions in our system. So there's various charts that we can do. A custom chart here is known as the response time chart. So it's a simple bar graph that just looks at all of the different transactions in our system and how long they're taking to perform. So we select the architecture here and the two different connection types we'd like to look at the results for. Click Finish, and we get a simple chart here showing all the response times. Now you can see here that the yellow line is the deadline, so there's a few transactions that are missing the deadlines, but in general everything's okay. Alright, so going back to our architecture now, furthermore we can look at the HO2 server down here, and we know that we've put extra load onto that, so let's just have a look at what its utilization is. We can see here that it's 53%, so that's fine, we can accept that as a performance. So it looks like we're going to save ourselves $600,000 and the performance will be okay. Let's have a look at another one of our evaluators, reliability. We want to see what sort of benefit or cost we've had by changing that application around. So again, we select the architecture, then we go through here and select the portions that we don't want to include in our simulation. So through this you can do lots of different scenarios as well on top of the, obviously this gross scenario that we're doing, that is the evolution that we're looking at. But anyway, we've chosen the parts of our architecture we want to do. Likewise, let's just have a look at the connections that are related to this change that we've done. So we can just choose a few of the connections here to make the simulation go a bit faster. We know that we haven't made changes to the others. So anyway, so we've got those 7 connections that we want to have a look at. We'll do a quick simulation here. In this case it's Monte Carlo. You can see down the bottom there a progress bar ticking away. So in this case what we're doing is running lots of iterations, failing the different things at the rates that they fail, the different bits of infrastructure fail and then are repaired and things like that, and having a look at what sort of effect that has overall for the architecture. Because what we're trying to find out, of course, is has there been an adverse effect by making this change. So it's ticking along there. Another sort of 20 seconds. Alright, it's ready to finish, so there you go, it took 36 seconds. So what we want to look at now is what is the overall reliability for this architecture. So again, look at the architecture node, look down the bottom here and we can see that the overall availability is 99.74 for this architecture. Now how does that compare to our previous architecture? So 99.74 compared to, if I get it to expand again here, 99.69. So it's gone up a touch. Little bit of improvement on reliability, but overall what we want to now look at is all of the different metrics. So we have another standard chart that we use to do that. It's called a capability space graph. It's essentially a radar chart. So let's choose the two architectures we're looking at here. Okay, let's choose all the different metrics that we're monitoring at the moment and just have a look at those on a simple graph. So we can see a radar graph there. I'll just collapse this window, the Explorer view, so we get more size. So we can see here for the two different architectures, starting with the actual architecture, the green line there, and then the potential future state, the red line. So what we're seeing here is that the response times are coming down, so that's good to see. We're seeing that in general we've got rid of some of the overloading in there, and here the reliability has increased. So that's good to see, and the cost difference here, it's gone down a little bit, but it's difficult to see at this resolution. So what we can definitely say is that this architecture looks like it, this evolution, looks like it will be worth doing. So we could retire some people, change some technology, and just like that, in 10 minutes' time, we've got an understanding that this would be worth an evolution.